Hey, Algebra 2. We are starting Unit 5, which is solving quadratic equations. What we did last chapter was, of course, graph quadratic equations, as you know, our vertex form and all our forms. So now what we're doing is solving them. And I will show you, there's lots of methods. As you can see here, we have all these essential questions. We're going to start today with how you factor out the greatest common factor of a quadratic function. It's a way to solve them. And I'll show you that. We'll work on that as we go through the notes. Hopefully you have the notes. I got to give the B students their notes, the A students, A schedule, you guys. So sorry that I didn't get to give you your notes. I thought we'd be in school Monday. I should start giving notes out always, right? Anyway. Polynomials are terms that have whole number exponents. Sometimes we have polynomials that are called monomials. Okay, one term, something like this, negative 3x squared. Okay, notice the exponent 2 is a whole number. Now, whole numbers are 0, 1, 2, 3, 4. Okay, there's no fractions, there's no negatives. It's whole number exponents. Binomial, two terms. Okay, negative 3x squared plus 7x. Okay, they have two terms. This is a term. Terms are separated by either a plus or a minus. Okay, this is a negative, not a minus. So this is two terms, and then a trinomial, just like a tricycle, has three terms, like a tricycle has three wheels. Negative 3x squared plus 7x minus 10. Okay? So we basically are going to be focusing on this type, the trinomial, okay, because that's our quadratic. If you think of our standard form of our quadratic that we just graphed, ax squared plus bx plus c, okay, we'll mostly be dealing with a trinomial, but sometimes we'll have more than that. Hey, if there's more than three terms, we just call it a polynomial. Say this is a polynomial with 4 terms, or this is a polynomial with 5 terms. Okay, these are the ones that have the special names: monomial, binomial, like a bicycle, trinomial. Okay. So on your whiteboards, let's go back, or not on your whiteboards, on your, that's old. That's whenever we were in school, or I thought we'd be in school. I'd like you to distribute the 4x through. We're going to take this monomial times this binomial. Okay. Product of a monomial and two binomials, etc. If you could just try that for a second. Pause me and try it, okay? When you come back, you'll see the answers. Pause me. Try it on a piece of paper. Okay, hopefully you paused me and you're back. When I took 4x times x plus 7, okay, 4x times x, remember you add the exponents. So there's an understood 1 here as the exponents. 1 plus 1 is 2. So that's 4x squared plus 4 times 7 is 28, 28x. Okay, we ended up getting a binomial. When I took this, 4 times x plus 1 times x plus 7, we FOIL the x plus 1 times the x plus 7, x squared plus 7x plus x plus 7. Combined 7x plus 1x is 8x, and then multiplied 4 through. We got another trinomial, or we got a trinomial that time. And the same thing here. Look, I have a 4, and I have 2 binomials, but this time I only got a binomial as my answer because my middle terms ended up canceling out, right? Negative 7x plus 7x was 0. So I ended up with 4x squared minus 196. So here I got a binomial, here I got a trinomial, and here I got a binomial. But what we're going to be doing this section is going backwards. Okay? What happens, guys, is we're going to give you this as the question. 4x squared plus 28x. And we're going to say factor it. Factor it. Factor means write something as a product, okay? And that's what we're going to want you to do. We want you to be able to get from here back to there, Okay, this is going to be the question. We're going to want to get you from here. This is going to be the answer. Okay, the question will say, factor this trinomial. Factor this binomial to get it back to here. Okay, that's what we're doing in this whole chapter. And what we're starting with first is something called the greatest common factor. So let's start with just numbers, how to find the greatest common factor of numbers. Okay, you did this in middle school. Okay, but it's something that people struggle with. Let's say the cheerleaders want to raffle off their goodie bags. Okay, they want to get rid of all their leftover inventory from the spirit stand. They have 24 Hershey bars left over. They have 16 movie passes left over, and they have 40 little toys that they had sold. They want to put the same amount of things in each bag. Okay, so they're wondering how many bags they can make so that they have the same number of Hershey bars, the same number of movie passes, and the same number of toys. What do you think? How many bags can they have so that that would happen? Let's see. We want to figure out what goes in to 24. The factors of 24 are 1. Let's just write them all out. 1 times 24. 2 times 12. 3 times 8. 4 times 6. And we're pretty much done. Okay, that's usually how I try to write it. I start with 1, then I know 24, that's going to be, and then, so there's 1, 2, 3, 4, 5, 6, 7. Oh, there's a lot of factors there. 16. I know 1 times 16. I know 2 goes into 16, 2 times 8. 3 doesn't go into 16, 4 times 4. Okay, well, I made too much room there. 1, 2, 4, 8, and 16, 40. We got 1 times 40. We have 2 times what, 20? Does 3 go into 40? No. 4? Yep. 4 times 10. Does 5 go into 40? Yep. 5 times 8. Okay. Then we're trying to find the greatest common factor. So I look, 1 is in common, 2 is in common, 4 is in common. 5, 6, no, they're not in common. 8 is in common. That's the biggest, isn't it? 8 is the biggest number that goes into all 3 of those numbers. Okay? So 8 is the greatest common factor. So going back to here, if I can make 8 bags, right? As long as, so each bag is going to have 3 Hershey bars. They'll have 2 movie tickets, and they'll have 5 toys. I can make 8 bags exactly the same that have 3 Hershey bars, 2 movie tickets, 5 toys. I got the bag number 2. I have 8 bags of the same, give them out or raffle them off or whatever we're going to do. Okay? That's how we use a greatest common factor. Now, there's different ways. I can list them like this. I could have also found the prime factorization. I don't know if you remember this, but we use there's only one unique way to write the prime factorization. 24, I know is, I'm just going to start with 4 times 6. 4 is 2 times 2, and 6 is 2 times 3. So the prime factorization of this, now that because I can't take 2 any further, I'm not going to write 2 times 1. Okay, once you get that far, you're done. I have 2 times 2 times 2 times 3. So that's 2 cubed times 3. Remember this? Prime we get to where we have prime numbers where they only have factors of itself and 1. 16 is 4 times 4. 4 is 2 times 2. 4 is 2 times 2. So 16 is 2 times 2 times 2 times 2. That's 2 to the 4th. 40 is 4 times 10. 10 is 2 times 5. 4 is 2 times 2. 40 is 2 to the 3rd times 5. So the greatest common factor, what we look at now for the greatest common factor is what they have in common. They all have a 2 to the 3rd, right? This has a 2 to the 3rd in there. It's the smallest, 2 to the 3rd, and it has an extra one, but okay. So 2 to the third, 2 times 2 times 2 is 8. That's another way to find the greatest common factor. That's of numbers. For variables, the greatest common factor is simply the smallest exponent. So the greatest common factor of 6x squared and 9x, what's that? 9x to the 1. So the smallest exponent is 1. So I find the greatest common factor of 6 and 9. The biggest number that goes into 6 and 9 is 3. And then between the exponents, we take the smallest exponent, which is x to the first. Okay, so you do the GCF of the numbers, and you do it you either use the prime factored way or you just list them out. Find the GCF of the numbers, and then with the variables, you just take the smallest exponent. Okay, so choose a method, either listing them out or prime factored, and find the greatest common factor of these pairs of numbers. 10 and 50x. Well, right away I can tell you that's going to have an x. Okay, that's the, oh no, it's not. What am I saying? I'm sorry, this doesn't have an x. It doesn't have an x. The next one, though, let's see, the next one will have an x squared and x. This one will have an x to the fourth and x squared. The smallest number there is x squared. Okay, so I got the variables done. Now I just need to figure out what's the biggest number that goes into 10 and 50. Well, that's 10 itself. What's the biggest number that goes into 40 and 95? I'd have to figure that out, right? Again, kind of pause me and see if you get these answers, okay? 40 and 95 I have over here. It looks like 5 is the biggest number that goes into 40 and 95, so 5x is the greatest common factor of 40x and 95x squared. 18 and 63, the biggest number that goes into 18 and 63 is 9. And the smallest of the variables was x, so that's 9x. 32x to the fourth and 92x squared. If you look at 32 and 92, look at the common factors. The biggest number that goes into both is a 4. So the greatest common factor is 4x squared. Greatest common factor here, 9x. Okay, see if you can get those, working them out yourself. Okay, now we're going to factor the greatest common factor from these polynomials. Okay, so first we have to find the greatest common factor, and then we factor it out. Okay, you can pause me and try it. Okay, so we found, we first noticed that 5 could be taken out of both. And then we got a 7x squared minus 63x. Then we tried a 7. Okay, and got 7x minus 9. That's one way to try it. Or we just take 245 and 315 and figure out that the greatest common factor of that is 35. Okay, by our old methods. I knew that the greatest common factor of the variables was just going to be x. Okay, so if I take 35x out of each of these, and sometimes I just write 35x underneath it. Do on your calculator 245 divided by 35, you get 7. Do 315 divided by 35, you get 9. Okay, and as far as why is this just an x? Well, it was x squared divided by x. That's just x. This one was x divided by x. They cancel. X divided by x cancels. Okay, so come back and we'll try, do these other two and come back and look at it, look for these answers on part 2. Okay, see you in a couple.